Good morning and welcome to video number 221. In today's video, we are going to discuss about an answer to the question of whether an instrumental variable is a panacea or a remedy for all econometric ills. Let us suppose we have these two models, one is y and one is x1, where x1 is an explanatory variable in the first model. So think of these two models in mind. The question is, why do we use instrumental variables? Instrumental variables estimation is used when our model has endogeneity problem. That is, when the covariance between any x variable and the error term is not equal to 0. Therefore, instrumental variable can be used to address the problem of omitted variable bias. In addition to this, instrumental variable can also be used to solve the classic errors in variables problem. Now a question is, what is an instrumental variable? In order for a variable z to be a valid instrument for x, the following condition must be true. Number one, the instrument must be exogenous. That is, the instrumental variable must be exogenously determined and it must not be endogenous. It means the covariance between z and u should be equal to 0. The second condition is that the instrument must be highly correlated with the endogenous variable x. That is, the covariance between z and x is not equal to 0. In order to use or to choose an instrument, we must use common sense and economic theory to decide if it is sensible to assume that the covariance between z and u is equal to 0. We can test if covariance of z and x is not equal to 0. We can just test the null hypothesis in the second model that I showed in the first slide, that pi 1 is equal to 0 in x is equal to pi naught plus pi 1 z plus v. Sometimes we refer this to regression as the first stage regression. For y equal beta naught plus beta 1 x plus u, and given our assumptions, covariance of zy is equal to beta 1 covariance of zx plus covariance of zu, so that beta 1 is equal to covariance of zy divided by covariance of zx. Then the instrumental variable estimator for beta 1 is beta 1 hat summation zi minus z bar into yi minus y bar divided by summation zi minus z bar into xi minus x bar. The homoscedasticity assumption in this case is that the expected value of u square given z is equal to sigma square. As in the OLS case, given the asymptotic variance, we can estimate the standard error as follows. You can see standard error in instrumental variable case differs from OLS only in the R square from regressing x on z. Since R square is less than 1, instrumental variable standard errors are larger. However, instrumental variable is consistent while OLS is inconsistent when covariance of x and u is not equal to 0. The stronger the correlation between z and x, the smaller the instrumental variable standard errors. The question is, what if our assumption that the covariance between z and u is equal to 0 is false? That is, that when the covariance of z and u is not equal to 0. The instrumental variable estimator will be inconsistent too, like OLS in this case. And we can compare the asymptotic bias in OLS as well as in instrumental variable case. So we will prefer instrumental variable if the covariance of ZU divided by correlation of Zx is less than correlation uh, of X and U. Estimation in the multiple regression case. Instrumental variable estimation can be extended to the multiple regression case, and we can call the model we are interested in estimating the structural model. Our problem here is that one or more of the variables are endogenous. In this case, we need an instrument for each of the endogenous variable. We can write the structure model as y1 is equal to beta naught plus beta 1 y2 plus beta 2 zi plus ui, where y2 is endogenous and z1 is exogenous. Let us suppose in this model y2 is an endogenous variable, that is the covariance between y2 and u1 is not equal to 0, whereas zi is exogenously determined. And let us assume that z2 be the instrument, so the covariance between z2 and u1 is equal to 0, and y2 is equal to pi naught plus pi 1 z1 plus pi 2 z2 plus v2, where pi 2 is not equal to 0. This reduced form equation regresses the endogenous variable R on. This reduced form equation regresses the endogenous variable R on all exogenous variables. So it is possible to have multiple instruments, and we can consider our original structural model and let y2 is equal to pi naught plus pi 1 z1 plus pi 2 z2 plus pi 3 z3 plus v2. Here we are assuming that both z2 and z3 are valid instruments. They do not appear in the structure model and are uncorrelated with the structural error term u1. Best instrument. We can use either z2 or b3 as an instrument. The best instrument is a linear combination of all of the exogenous variables. That is y2 star is equal to pi naught plus pi 1 z1 plus pi 2 z2 plus pi 3 z3. And we can estimate y2 star by regressing y2 on z1, z2, z3, and we call this first stage equation. If then substitute y2 hat for y2 in the structure model, we get some same coefficient as instrumental variable estimation. While the coefficients are the same, the standard errors from doing 2 SLS, that is 2 stages least square by hand, are incorrect. So let Stata do it for you. If we use Stata, Stata will compute these standard errors for us. And the method extends to multiple exogenous variables. For this, we need to be sure that we have at least as many excluded exogenous variables as there are endogenous variables in the structural equation. Remember that the classical errors in variable problem where we observe x1 instead of x1 star, where x1 is equal to x1 star plus ei or e1, and e1 is uncorrelated with x1 star and x2. If there is a z variable such that the correlation of z and u is equal to 0, and the correlation of z and x1 is not equal to 0, then in that case, instrumental variable will remove the attenuation bias. We can also use IV for testing endogeneity. Since OLS is preferred to instrumental variable if we do not have an endogeneity problem, then we would like to be able to test for endogeneity. If you do not have endogeneity, both OLS and instrumental variable estimation are consistent. And the idea is of a Hausman test to see if the estimates from OLS and instrumental variable are different. While it is a good idea to see if instrumental variable and OLS have different implication, it is easier to use a regression test for endogeneity. If Y2 is endogenous, then V2 and U1 from the structural model will be correlated. The test is based on this observation. And we can save the residuals from the first stage regression. We will include the residual in the structural equation. If the coefficient on the residual is statistically significant from 0, we reject the null hypothesis of exogeneity. If multiple endogenous variables jointly test the residuals from each first stage regression, we can also use IV for testing or identifying restrictions. If there is just one instrument for our endogenous variable, we cannot test whether the instrument is uncorrelated with the error, and we say the model is just identified. If we have multiple instruments, it is possible to test the or identifying restrictions to see if some of the instruments are correlated with the error. The or identification test. In order to do that, let us estimate the structural model using instrumental variable and obtain the residuals. We will then regress the residuals on all of the exogenous variables and obtain the R square to form n times R square. Under the null hypothesis that all instruments are uncorrelated with the error term, the Lagrange multiplier has a chi-square test where Q is the number of extra instruments. We can also use IV for testing for heteroscedasticity. When using two SLS, we need a slight adjustment to Bruch-Pagan test, and we can get the residuals from the IV estimation, regress these residuals squared on all of the exogenous variables in the model, including the instruments, and we can test for the joint significance. Similarly, we can also use IV to test for serial correlation. When using two SLS, we need a slight adjustment to the test for serial correlation, and in the same way, we can get the residuals from the instrumental variable estimation and then re-estimate the structure model by two SLS, including the lagged residuals, and using the same instrument as originally. And we can do two SLS on quasi-differenced model using quasi-differenced instruments. Ladies and gentlemen, I hope you might have got some answers to the question of whether IV estimation is a panacea or a remedy for all econometric ills in estimation. Although it is not a perfect panacea, but instrumental variable estimation can solve many of our problems that are relevant in the case of omitted variable bias, in case of heteroscedasticity, in case of serial correlation, in case of classic errors in variables, measurement, and so on. Thank you very much for watching this video. You can share this video, you can like this video, and you can subscribe to this channel if you haven't yet. And do not forget to click on the bell icon so that you can get notification about other important and informative videos that I'll do and upload for